So in this video is just an introduction to linear functions and also the axes that we're going to draw the functions on. The first few videos will be how to sketch linear functions, and then we can sketch quadratic functions and then hyperbole and maybe even exponential functions. But we'll stick to 2 dimensions, and then in later videos I'll maybe do 3-dimensional graphs. Okay, so let's start. If you think about graphs, we're first going to start with the number line. So I hope you're familiar with one. So we can put maybe 0 here, and we know on the left hand side we have maybe -1, and then we can have -2, and then it just goes on forever in the negative side. Then on the right hand side we can have maybe a 1 here, and then a 2 here, and maybe a 3 here. Now I know it's not always possible, but we always try and keep the distance between the two numbers equal, because the distance between 1 and 2 is the same as the distance between 2 and 3. So then if we go to 2 dimensions, we have 2 axes. We have the horizontal x-axis and we have the vertical y-axis. So we always label them. I have lost lots of marks not labeling my axes, so always label them x and y. Now let's say you have a function that is a function of, let's say, t and p, then you'll label this here p and t. So that's why I said in my previous video, that's why we always use x and y, because they're known as the x and y axes. But you can also label them for the variables that you are using. Okay, so let me just take them away. So just as the same at the top here, right here in the middle, we have the point 0, 0, because that's where x is 0 and where y is 0. Then on the left hand side here, at this side here, the x is negative. So this point here is -1, we have -2, we have -3, and then on the right hand side here we have 1, we have 2, we have 3, and this just goes on forever in each direction. Then for the vertical y-axis, so the x-axis is horizontal, the vertical y-axis, on the top we have positive numbers. So here we'll have 1, then we'll have 2, and then we'll have 3. Then at the bottom here we'll have -1, we'll have -2, and maybe -3. And this also just goes on in each direction. So a point on the axes is always labeled x first and then y. So if we'll have maybe a point 1, 2, we go to the x-axis, to the positive side, we find 1, and we go up 2. So that point there is the point 1, 2. So the same we can do. Let's say we have a point 2, -3. So then we go to the 2 at the positive x-axis, and we go down 3. So that point there is the point 2, -3. Then we can do the same for each quadrant. So we usually have, this is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. So let's say we have the point -2, 3. Then we go to the negative x-axis on the left-hand side, so -2, and we go up 3. So the point there is the point -2, 3. Then we can also maybe have -1, -3. So we go to the -1 on the x-axis and we go down 3 units. So that point there is -1, -1, 3. Now -1 minus 3. So I'm just going to explain the quadrants now. So in the first quadrant, we have that x is greater than 0. So let me really draw this. So in the first quadrant, we have that x is greater than 0 and y is greater than 0. In the second quadrant, which is the one here, we have x is less than 0 and we have y is greater than 0. Then in the third quadrant, we have, which is the one down here, we have x less than 0 and y less than 0. Then in the fourth quadrant, we have x greater than 0 because it's the right hand side there, and we have y less than 0 because y is negative at the bottom. So the general form of a linear function is y is equal to mx plus c. So just to make it sometimes easier to label your functions, the ones which you graph, you'll have f of x is equal to mx plus c, and you'll have maybe g of x is equal to mx plus c, and you can have a third function, h of x is equal to mx plus c. So you can actually use j of x, maybe c of x, but let's say the test uses g of x and f of x. You can't just switch it to h of x and c of x. But if you're doing your own functions, then it doesn't really matter. It's just to label your functions. So usually m and c are whole numbers, like y is equal to minus 6x plus 5. So then m is equal to minus 6 and c is equal to 5. But you can also have y is equal to, let's say, 8.456x minus 14.678. So this type of functions here are just a little bit more difficult to graph. So I'll do example where the m and c are not whole numbers, but usually they are. So you can write maybe then f of x is equal to minus 6x plus 5, and you can have g of x is equal to 8.45x minus 14.678. So then when you draw them on these axes here, you can label them. So you can maybe label them g of x and maybe another color, make it f of x. So then you don't have to write the whole function next to the graph to show which one it is. So if you have only one function, then it's quite obvious that's the only function there is. But if there's more than one, it's better to label them, so if you show it to other people, then they know which function corresponds to which drawing. So you'll maybe seen that in this case m is positive, but in this case m is negative. And here c is positive, but here c is negative. So if m is greater than 0, then the linear function has a positive gradient. But if m is less than 0, then the function has a negative gradient. So how I like to think about it, if m, let me just have a thicker pen, if m is greater than 0, then I think about a check mark. So then the function will have a positive gradient. It will go from the bottom left to the upper right. But if m is less than 0, then it will have a negative gradient. So how I think about it is the n for negative, it will have a negative gradient. It will go from the upper left corner to the bottom right. So I just think about this part here of the m. So it will have a negative gradient. Then, if c is less than 0, then the function, or the linear function, will cut the y-axis at the negative side. So it will cut the y-axis somewhere in the negative side here at the bottom. But if c is greater than 0, then it will cut the y-axis on the positive side. So where y is positive, so it will cut it on the top here somewhere. So somewhere on this part here. So that's just the introduction of linear functions. The next 3 videos will be 3 methods on how to graph them, and I'll use the same functions for each of them so you can see the different methods. So thank you guys for watching. I really hope you enjoyed it and learned something, and please consider subscribing and liking this video.